All right, so this is section 310 and 311. And in this section, I've kind of combined these two sections together because the approach to these problems is very similar. So we will do an example of polynomial inequalities as well as rational inequalities. And anytime we are solving either a polynomial or a rational inequality, we want it to be equal to zero. So no matter what kind of inequality you have, you need to have zero on one side. And so we want it in that form. And then once we have it in that form, we are going to factor and solve that equation once it's set equal to zero. And those are going to give us what are called the boundary points. Once we have those boundary points, we're going to put them on a number line and then choose a test value in each interval. And then we're going to check if it gives us a positive or a negative value in each of those intervals. And then depending on whether we wanted it greater than zero or less than zero, we will write our solution in interval notation. And then also give a graph answer as well. So in this first example here, it is not set equal to zero yet. So the very first thing I need to do is set this equal to zero. So subtracting 15 from both sides, I have 2x squared plus x minus 15 equals 0. Well, we've been factoring things like this all semester. I use the x method. 2 times negative 15 is negative 30, and 1. 6 and negative 5 multiply to negative 30 and add to 1. So I have 2x plus 6, 2x minus 5. And in the method, I use the X method. This step I called taking out the trash that I taught earlier this class. And that gives me x plus 3 is equal to, or times 2x minus 5 equals 0. And those are my two factors. You can multiply them out and check, but it does, if you multiply these out, get you back to what we started with. So my boundary points are x equals negative 3 and x equals 5 over 2. If you set each of these equal to 0 and solve them, that's what you get. So those are our boundary points, and that's what we're going to put on a number line here, negative 3 and 5 over 2. And I need to choose a test value in each of these intervals. So something less than negative 3, something between negative 3 and 5 halves, something bigger than 5 over 2. 0 is always a nice number, and that's between negative 3 and 5 over 2. 3 is bigger than 5 halves, and negative 4 is smaller than negative 3. You can choose any value you want as long as you are picking something in each of these intervals. Now, if I plug in negative 4 plus 3 is a negative. Negative 4 times 2 is negative 8, minus 5 is negative. A negative times a negative is a positive. If I plug in 0, 0 plus 3, that's positive. 0 times 2 is 0, minus 5 is negative. A positive times a negative is a negative. And then plugging in 3, 3 plus 3 is 6, that's positive. 3 times 2 is 6, minus 5, that's positive. Positive times a positive is a positive. These signs do not always alternate like this, so don't make that assumption. You need to actually test every interval. So this question is asking us, where is this polynomial greater than 0? So we want it greater, oops, should have been strictly greater than here, not equal to, sorry. Greater than 0. So I want where that's greater than 0. Well, positive numbers are greater than 0. Negative numbers are less than 0. So I want where this thing is positive. So the way you're going to write your answer is a new number line here, negative 3 and 5 over 2. We have a strictly greater than inequality, so I won't have the closed dot. It'll be an open dot at each of those values. And then it was positive over here and over here. So that's what your graph will look like. And then your interval notation will be negative infinity to negative 3. We're using parentheses because these are open dots. And then 5 over 2 to infinity. Again, parentheses because they are open dots. And that's the way you would write your answer, including both the graph and the interval notation. All right, on to the next example, which is a rational inequality. And you can see here that the steps are basically the same. I've just much abbreviated them rather than copying and pasting both of the long directions. So again, we want the inequality set equal to 0. We want to set the top and bottom equal to 0. Those are our boundary points. And then we're going to put those numbers on a number line, choose a test point in each interval, and then write our solution. Now, right now, this is not set equal to 0. So the very first thing I need to do is get it set equal to 0. Subtracting 2 to the other side, I have x plus 1 over x plus 3 minus 2. So I've just subtracted 2 to the other side. I need this side to be a single fraction. So instead of just having this 2 here, I need to create a common denominator. So I'm going to multiply on top and bottom by x plus 3 over x plus 3. And the reason I'm doing that is because the denominator over here is x plus 3, and this gives me a common denominator. So I have x plus 1 over x plus 3 minus 2 times x plus 3 over x plus 3 greater than or equal to 0. And actually, I'm going to go ahead and distribute that 2 now. So that'll be 2x plus 6. So again, I just distributed the 2 here. And now writing that as a single fraction with x plus 3 as our denominator, I have x minus 2x is negative x. 1 minus 6 is negative 5, again greater than or equal to 0. So now I have a single fraction set equal to 0. I can go ahead and set the top and bottom equal to 0. Negative x minus 5 equals 0, and x plus 3 equals 0 gives me x equals negative 3. And adding 5 dividing by negative 1, x equals negative 5. Number line with each of those values. And I want to choose a test point in each interval here. I could choose 0, I could choose negative 4, and I could choose negative 6. And I want to plug those in and see whether they are positive or negative. Plugging in negative 6 times a negative is positive 6. Positive 6 minus 5 is positive. Negative 6 plus 3, that's negative. So a positive divided by negative is a negative. I'm talking through this all in my head, but if you feel like it would be really helpful to write out the values, you can do that. You can do negative times negative 4 minus 5 over negative 4 plus 3. And then you have negative times a negative, that's a positive 4. Positive 4 plus negative 5 is negative. Negative 4 plus 3 is negative. A negative divided by a negative is a positive. If that's helpful for you, do that. If you're able to talk through it in your head and do it correctly, then that's fine too. Plugging in 0, this term is 0, this term is 0. A negative divided by a positive is a negative. Now this question asked us, where is it positive? And it's positive between negative 5 and negative 3. Now we have to be really careful because this problem is actually a little trickier than it may initially appear. This is an equal to inequality, so I should be using closed dots for both of these, but one of these values would make my denominator 0. If I actually let x equal negative 3, well, negative 3 plus 3 is 0, and I can't divide by 0. So even though this has an equal to inequality, because this value would make my denominator equal 0, I have to use an open dot. The equal to sign means I should be using closed dots, but because this value is an excluded value, I cannot include it in my answer. But I do want the shaded area between those two values. And so in interval notation, my answer would be negative 5 to negative 3, a parenthesis, an open dot at negative 3, closed dot and bracket at negative 5. And that brings us to the end of section 10 and 11 and the end of chapter 3.